Okay, so to refer to a particular value in a NumPy array, we work in the same way as we would for a list. We specify the index of that value, and we always start with the outermost dimension. It's all getting very, very Star Trek here, but we start with the outermost. So think about if we've got nested, it's a bit like nested loops or nested brackets. We start with the outermost thing and then carve our way in. So obviously, if we've just got a one-dimensional array, that's just like a standard Python list. So that's easy. If we want the first element, we'd just say index 0. So we start from 0, as with lists, and we give the name of the array, and then in square brackets put the index. So one-dimensional array, no problem at all. Two-dimensional array, we need to start from the outermost dimension, and we already saw a little example of that when we had a list of lists, I think last week, where we give the index of the outermost dimension and then the index of the next dimension as we drill in. So here, if we imagine we've got a two-dimensional array, so our outer square brackets, the pink ones here, that's effectively, imagine that as our list of groups, and we've got 3 groups. So what this says here is give me the second group, the one with index 1, so that's this one, and give me the third person in the third value in that group with index 2. So 0, 1, 2, that will give us the value 6. Okay. Same applies for a 3-dimensional array. You start from the outermost dimension, and we have to give in square brackets the coordinates of each dimension. So here, this would say start from the outermost, so that will be the pink here. So here we've got a list of groups within various departments. So this is maybe department A, this is department B, and each of them's got 2 groups. This says give me the second department, give me the second group, and give me the 4th individual within that group. So that'll give me this value here. You can see how this gets a bit difficult when you've got 100 dimensions. But don't worry, this isn't how you tend to refer to elements in that way. So just like with lists as well, we can use slicing. We looked last week at how we can slice lists to carve out a bit of a list in order to only return particular values from that list that we want. We can do exactly the same with a NumPy array. So imagine this is my NumPy array. It's a simple 2-dimensional array here. I've got basically two groups of numbers. So we can slice it. So if we slice it in this way, again, we use the square bracket notation after the name of the array. This says here, from the first element, remember it's starting from the outermost, so from the first group, give me back the first 3 values. So this is up to, but not including the value at index 3. So that will be the ones with indices 0, 1, and 2. So in this case, that will give me back 1, 2, and 3. First group, so outermost dimension will give us this, and then within that group, I want the first 3 elements. And then similarly, this slicing example here, we can use a completely empty colon. I think we looked at this last week for lists, I can't remember now. But a completely empty colon means, no, I don't think we did actually. This means give me from all lists, so in the outermost dimension, from both of these lists, give me back the elements from 1 up to, but not including index 4. So in other words, indices 1, 2, and 3. So from both lists, give me back the second, third, and fourth elements, basically. So 2, 3, and 4 from the first list, and 7, 8, and 9 from the second list. And that scales up to 3-dimensional plus arrays, just makes your head hurt a little bit more. So this, again, start from the outermost dimension. This says so again, imagine this is 2 departments, each of which has 2 groups with 5 individuals in each. This basically says from both of the outermost groups, give me back the first list in each, but only give me the first 2 elements of that. So that'll be 1 and 2, and 2 and 4.